Well, I think it's 3 o'clock. This is packagekit. Can you all hear me? Okay, right, I crack on. First of all, my name is Richard Hughes. I maintain Gnome Power Manager. I'm co-maintain. Okay, I'm maintainer of Gnome Power Manager. I co-maintain OHM, and I contribute to HAL. If you're using a laptop right now, which is probably the majority of you, just check out packagekit.org, and there's some screenshots and other cool stuff. What I'm basically going to tell you is the problems that we've got at the moment, the competitors as I see them, and also a possible solution. So, we suck. We really do. Thank you. We build kick-ass packaging formats like RPM, DEB, etc. 1995. We layer on cool depth solvers and auto-downloaders to make it a little bit simpler. And then we try to bolt on a UI on top of an existing stack. Now, this just doesn't work. If we want to have updates without passwords, it's just impossible. What if we want to use fast user switching? What if we have 2 different sessions in 2 different locales? It's just impossible. What if we want to have commons tools? One using apps, one using Yum, which is impossible. So, what should we have done? We probably should have looked at actual user interaction and designed the tools around the use cases. Seems sane enough. But we can't do that because apps is Debian, RPM is Fedora, and all the distro build tools are built around the tools. So we can't just replace everything wholesale. So hence what I'm giving this talk. What we actually need to achieve is actually quite limited. We just need to keep a system updated, install new software, and have sane user interactions. We need to work with GNOME, be integrated in the desktop itself, and with KDE, XFCE, or any desktop you want to use. We have to work with Yum, Canary, apt-get, Box, Zip, Emerge, and all the other backends in existence. And we probably shouldn't break all the existing package tools, because a lot of people are quite keen on apt-get, quite a lot of people like Synaptic, and sure, everyone's different. So what we've done in the past, we seem to have done different tools per distribution, which just we can't do that long term. Fedora, Pirate, Ubuntu, no map install, update manager. SUSE, we've got a GUI on top of libzip and the Zen updater thing. And basically the others, it's the same shit, different day. So, we need root passwords. Now, if I'm searching for a package, why do I need the root password? Just not necessary. What the hell's GPG? If I install the system for my mum or someone who's not IT literate and asks them to confirm a GPG key, that's meaningless. It's just pointless displaying it. We can't do things like multiple users. And so if we have one locale in, say, French with my girlfriend, and we have another locale in English with me, and I switch, all the errors will be in the wrong language. So we don't stick to any of the GNOME UI specifications or KDE UI specifications. Something like Pirate, something like Python, and so we sort of take a sort of halfway ground between KDE, XFCE. It's just a bit of a bodge. We typically badly design them because there's typically only one distro guy making the tool, and it's probably translated by the distro, and therefore it hasn't got the full upstream sort of localization. It lets us do really crazy things, like start installing a system or updating a system and pressing the power button, and it powers down. Therefore, you lose your RPMDB, reinstall, etc. It also updates on the train when we're on battery power, which probably isn't a very sane thing to do. When I'm using GPRS on a train, I probably don't want to do updates. So, let's see what we're doing wrong. Don't take any of this personally if you guys have actually done this. What on earth's that? I don't know what I'd click. I'm wanting to see what updates there are, or if there are any updates. So, what is this root password thing, and why do I need it? Something's running. Like in Fedora, I see that if I'm running a yum updates D in the background, and I'm seeing this on the foreground. So nothing I've run is running that's stopping me accessing information. So we're just locking needlessly. And we have errors like that, which is really useful. And like that. So, int source, no int source on media, I guess I would click yes, but I don't know. And apparently D0A, FFF59, etc. just isn't valid. Again, useless, absolutely meaningless. So, controversial. Vista does it actually quite well. It works with fast user switching. It downloads using Bits. Bits is background intelligent transfer system. And so it basically uses idle bandwidth rather than foreground bandwidth. It has a pretty same preferences pane, so we can actually see what's going to happen when. We provide really good feedback to the user, telling us what we're doing, and by default, we update, and so it stays secure. But then it does things like that. Now, I don't know what 8000 FFF is, but apparently I need help. So I'll try again. And I also am not sure what that's all about either. So, OS X, they've done things really well. They've looked at the user interactions and looked at what the user actually wants to do. It works with fast user switching, it downloads updates in the background, it has really sane preferences that I can understand, an update viewer which is pretty sane, and it defaults to automatically update, and so the system stays updated. Easy to use. Big difference. This is application rather than package. And so on OS X, I'm installing QuickTime. Now on Linux, we'll obviously be installing something like, I don't know, QuickTime-libs, QuickTime-devel, QuickTime-debug, and they all might have different dependencies which dragged in and have to be updated. So we can't really look at it from an application point of view. But I'll come back to this in a minute. Now, Ubuntu have done some really good stuff in this. Some of the stuff works really well, and the problems with it are mainly down to core design decisions. We can't really use fast user switching in different locales. We can't use a lockless operation, so if we open Synaptic, we can't open the update viewer. We don't really have an upstream preferences pane, but the update viewer is not bad. It's pretty good. It's best of the bunch. But Synaptic really scares my fiancée. She's not got a clue what to do. And no map install. Really looks fantastic. Really, really good interaction, but only works with Ubuntu. The backend's not particularly helpful. The update viewer, pretty good. Synaptic, not sure what that is. And app and remove applications, which is good. Now, a lot of you think in packagekit, if you've done a bit of research, you might think, how is it actually different from Red Carpet? Red Carpet was a few years ago. I think, in my opinion, it's well ahead of its time. Now it'd be much more successful. It was a daemon running all the time, and so unlike packagekit will only run and load the daemon when it's actually required. Novell Red Carpet was doing that all the time. It had an enterprise focus rather than a home user focus, so it wasn't particularly easy to use. It supported RPM and deb, but it replaced the depth solver and the downloader, which was the critical flaw, I think, for adoption, because the distro didn't want to relinquish control of the depth solver for the bodges and the downloader for the mirrors. And it never really reached a critical mass. So, main point of the talk. What is packagekit? It's basically a system designed to make installing and updating your system really easy. It should unify the graphical tools, and so we have some sort of sane user interaction. It should really make authentication really suck a lot less. At the moment, none of the distributions have done this correctly. It's not really designed to replace anything. And so if you want to use packagekit and Pirate or Synaptic, they should all live happily together. And we should never replace apt-get or yum, because that's just, well, heresy. And it's system activated. So as I mentioned, only when you use packagekit is the system daemon activated. Other than that, after 5 or 6 minutes idle, it will exit. So, this is how it actually works. It looks really scary, but it's actually really simple. Packagekit D is system context. It's running just once per system. And there's a system dbus interface to the client tools in the session. These tools, you've got to bear in mind, there could be thousands of these tools if it's a server, and they'll probably all be in different locales. And so we have to be very careful passing things like errors up the stack. Obviously, all three tools, or however many things can access packagekit simultaneously. The backend itself is basically a way of converting the distro tool to the packagekit common API, but I'll come back to that in a minute. The active queue lets you queue a running task. Now, a task might be something like search for a file that is located here, or update the system, or update the specific package. Now, tasks are fire and forget. So you have the task, you fire it, and it just does it. And then the active queue takes responsibility for queuing up actions for the backend. Now, the backend itself might need to talk to things that are Python, or written in Shell, or Perl, or anything. So there's three ways we can talk to a backend instance. The best one's probably using a dbus service, a persistent or a private connection. There's also a thread, so we can open threads and talk to something like libzip. We can use threads. Or if we haven't got any of that, we have to use Perl or something, we can use helper executables and use standard input, standard error, and standard in. So I've hinted what a backend is, but it's really simple. It's basically a really small compiled subobject. It provides a really, really simple interface. There's nothing complicated at all. It converts, it sounds complicated, but it basically takes the packagekit task and does it. And that's the only real bit that if you wanted to convert your distro to use packagekit, you'd have to write. And so if you wanted to, say, merge Canary and Canary functionality into packagekit, you write 900 lines of Python, or C, or whatever binding you've got. And you don't even have to have a complete backend. So if you're using something on a mobile phone, so like package or something, and you only support updating the system, installing software, and searching, you actually implement those methods. You can have incomplete a backend. In that instance, if the backend was incomplete, the UI elements would reflect that. And so if you can't update the package, it wouldn't give you an update button to click. Cool. So, PolicyKit. PolicyKit, most of you might have heard of PolicyKit before, and packagekit uses heavy use of PolicyKit to do the user authentication. That means the daemon's running as, well, root or a configured system user and is security sensitive. We can specify fine-grained control. And what that actually means is we can say anyone in the admin group can install anything. Anyone who is my girlfriend's logon can do updating the system without password. I can install and remove anything. And I can say that if someone wants to do something they can't, I can ask them for their own password or the administrator's password. So, for instance, an unprivileged user in a university could probably do updating and do searching, but can't install or remove packages, or install from a local file. So if it's an Ubuntu or a home distribution, we can ask the user for their own password, just to confirm they actually want to do the action. And one thing I've mentioned about PolicyKit is you can save the authentication per session, so that when you log out, it forgets your authentication, or do it per system, so it actually remembers across reboots. So, internally to packagekit, we have to abstract out certain things. And one of the key things is a package ID, which is basically like a Fedora Nevra, a unique way to identify a package. So there's name, version, architecture, and a bit of data. Now, the data field basically means the package ID has to be unique across every single repository. So normally the data field you can encode as the repository name. As I said, must be identified. Package IDs are never shown to the user because they're way too complicated. They're just not easy to use at all. I'll show what we show instead. So, filters. Search filtering is done in the back end, just to reduce the IPC. We can do installed. Is the package installed on the system? So we can see if something's installed or available in a repository or neither. We can also see if it's a development package. So if a user doesn't care about development packages, we can say, don't filter development. We can also do GUI filters. So we can say, does this program have any GUI element? So something like PowerTop wouldn't come up, but something like AbiWord would. Do we want just free software? Do we want software that's, say, the free Flash, or do we want the proprietary Flash? Do we want it to be visible? Some packages might not be useful to show in the UI, and so we can give it packagekit a hint that it shouldn't show them in a UI? And is it supported? Are we installing some random RPM, or are we installing some supported Fedora or Ubuntu package? Now, you don't actually have to support any of those. So your backend, your backend's got no way of telling if it's a GUI application, you just don't support that filter. And then the backend will be, the UI will reflect what you can actually do. So, you're thinking if a backend is something like Yum or Python, etc., we can't do dbus or whatever, we can't operate it in a thread, we can't do anything particularly useful, we can send it standard input and pass standard error and standard out. So we can have a little system that just communicates the standard out to internal packagekit API. And we can send the process a signal when we want to quit. Now, a lot of packaging tools don't like being Control-C'd, but in some cases that might be a sane thing to do. So we've got an abstraction which lets the backend, i.e. the thing that's talking to the distro package tool, when is it sane to allow a cancel? So if for instance I'm downloading, that's pretty sane time to cancel, but if I'm installing, that's a pretty insane. So on threads, we can't just kill the thread, we probably should do a nice cancel method, stick it in a loop, and kill the thread safely. And also we can get malicious and do sig quit, and then after a small delay, sig kill. So, error types, this is a bit quite controversial as well. All the daemon is in C locale, which basically means we need to enumerate the errors and other messages to set types so we can localize them in a front end. So, but we also probably want a description. So if it's a stack trace or something, or backtrace, etc., we can have it as a description, which is free text we could put in a Bugzilla or something. And that's obviously not converted. So for instance, out of memory, not supported, package not installed, and we can add as many errors as we need, because they're just abstract enumerated types, and we can just add tons and put them into the front end and translate them. Now, another concept is a transaction ID. Now that's something that identifies a present, past, or future transaction. And so when you actually ask for a transaction, you do fire and forget. That's a future transaction. A transaction that's running right now would be present, and past, something in the past. We remember the past transactions, so if you're using a backend such as Canary, and you want to do a rollback, you can roll back to a certain transaction where you can see what you actually did. A transaction itself, per transaction, there is many sub-transactions. And so for a typical transaction, there might be, you might download 2 files, you might install one of them and update a third. So there's many sub-transactions per transaction. But the transaction only ever has one role. And so the role might be update system, or search name, or install from local package. But it does have different statuses. And so the status value could be something like installing, downloading. This is useful for UI elements. So for example, a transaction ID could be something like just a free text number, bit of random text, and then a checkpoint, which could be something like, which could map directly to the Canary rollback number, for instance. So what can we actually do? Again, not all of these are supported in all backends. You don't actually have to support any of them. With search name, search group, search details, search file, pretty obvious ones. Remove package, get dependencies, and also resolve. Resolve lets us basically see, is a package installed, is it available, and it's a single file method. We can get details about an update, get requirements on a package, get the file list, etc., refresh any caches, etc., enable repositories, set data for repositories, and do service packs, so an offline CD, etc. But what do we actually get from packagekit? Packagekit's obviously got to be quite abstract, and so we've got to put things into very sort of closely defined API. So it gives you progress, like time, how much time things are going to take, percentage, etc. Any errors, actually what it's doing right now. If anything requires a restart, and so a restart type could be session, i.e. you need to log out and log back in. System, you need to shut down and boot up again. Or application, so you might just need to close the application down and reopen it. Packages lets us see the package ID and summary. and the other two aren't that interesting. So, that's the geeky bit. How do you actually use it? Easiest way is on the command line. So I can say pkcon is the default console client for packagekit, and I can get an update list. You see 0.1 seconds. That's using, I think, either the dummy or Yum backend. I can search for stuff, trivially. Now, the same commands work on anything with a packagekit backend. So if you're running Ubuntu, you're running Foresight, you're running Fedora, exactly the same commands will do exactly the same thing. But this is the more interesting bit. Now we've got this nice, common, abstract interface. We could do some really cool stuff. We could say, instead of making the user go and install the clip art himself, could we not install the clip art for them? And so this is like, I guess, what, 5 lines of code, which basically shows you how easy it is to install clip art. So you could do something like OpenOffice. You go to the clip art page, there's no clip art. Normally you see just a blank page. But you could say, there's no clip art installed. Do you want to install it? And if you've got permissions to install the software, you do it without a root password, and you can do it in a sane way across distributions. So, Qt. Qt has a nice front end for this, just some searching packages, developed by Adrian. It's not as polished as the GNOME ones yet, but it's work in progress. We also have GNOME tools, and they seem to work a lot better. You can see I'm searching for stuff with Poe in the name there, with installed, non-development, graphical, and doesn't matter about being free. You see I've got description, file list, dependencies, and required. So you can have dependencies going both ways. And also there's a groups tab, so you can actually choose things by group. The groups, again, are enumerated, and so we can just add tons of enumerated types, so the translators can just do a translation once, and the daemon can abstract it into a nice set type. So we've also got preferences. Now, this can be very integrated into the desktop itself, and so for GNOME, we can say this is a typical GUI, but KDE could have it as part of their control panel, because it's all completely neutral in terms of desktop. So I can say, I can hook into other session things, like GNOME Power Manager. I can say, when I'm on battery, don't install updates. And if it's my mum using this, I probably want her to just install the security updates, or any high importance updates. I don't want her to install everything. And I can also display notifications. So because it's fire and forget, we can actually say when you close the application and you've done a fire and forget method, you can say, I'll just close the application halfway through. If you're halfway through downloading something, close the application, still runs in the background. But I probably want to be notified using like libnotify when the application's finished. I sort of hinted earlier, with the package signal, we can return more interesting things. Now, we're trying to remove MathML fonts, which I didn't think I needed. And it's come up saying, actually, Abbey word actually needs it. So rather than displaying a package and then a version and unintelligible stuff, we can actually say to the user, what actually does it? Now, this text is localized, the Abbey word processor. The localization, if it's not supported by the repository, we can get that from the desktop file, or we can get that from Spexpo. So we can get this sort of localization offline from lots and lots of different places. We can enable repositories. Now, this is yet another policy kit rule. And so I can say, no one apart from me is allowed to change which repository I'm downloading from. It's a very abstract way that we can say that it's common between Fedora and Ubuntu. Now, this is one of the prompts. The wording's not brilliant, so don't go mad yet. But this is me. I'm trying to change a repository parameter and enable a repository. And it's asking me for either the root password, or I could make that the user password by changing a config file. And I can remember it permanently or just for the session. By clicking on details, I can see exactly what's wanting to be done by who, more for sort of debugging. Now, because we've got this nice abstraction, we can do some quite nice tools, and we can have overviews, pages, and all the sort of flashy stuff that macOS has. We just design them once. And so we fix everything in one central place rather than in Fedora, Ubuntu, SUSE, and all the others. We've got quite a powerful update description. So per update, we can get the metadata from repositories and display things like Bugzillas, CVE references. It's all quite flexible. And you see also, I could just, from this page here, do an update system, close the window, fire and forget, it just does it. One of the things that makes it more complicated is if something like apt wants to ask you a question mid-transaction, that's banned. That's completely banned. Any questions you have to ask about the transaction has to be done before it or at the end. Actually, doing it halfway through destroys the concept of fire and forget. So, if I've got security updates, I probably want to be notified straight away, and so I can get a notification like this. Because it's all session-side, it's localized. I can have a session preference, and so if I don't want to be warned because I know what I'm doing, I could just tick the little box on the right. But if someone else is using the system, they probably do want to be told. Obviously, this won't appear if it's automatically updating. There's just no point.
Just a question then on fast user switching. So if Fiance says don't call me again,
yep.
You switch your session, will you see that?
Yeah, because it's per session. So it's per user, because Anya might be using KDE, and I might be using GNOME. And so I can't really say that it's a session setting. I'll ask some more questions in a minute. Development itself is, I guess, pretty mad, because we went from nothing to a substantial product in maybe 5 or 6 months. All the development we do is done on a private server. It's a good server and a good connection. Thanks, Ken. Thanks, Elliot. They basically provided the server so we can have a local repository. You're thinking, why is that important? We can say to developers, push and pull on this fast server all through the day. As if they're all working together, so the Ubuntu guys, Fedora guys get together, work on the same stuff. We can push and pull 15, 20 times a day. And the best bit, we can create accounts. Doesn't seem that important, but if we're asking a new user with a patch to come along and say, okay, I need you to go through the free desktop account procedure, that could take a few weeks. By then, they've lost interest. So what I say to people, if you've got a patch, I'll give you commit. Now, that's quite controversial. But usually what happens is people have one patch to, say, fix the build or something, and because they've got commit, they have a real sense of power. They're committed to the project now. They feel part of the project. And so I've found that very few people who have commit don't keep committing. It's a great way to get people into the project. But with that means that anyone can check in practically anything into the repository. So what we do, once a day, we download all the changes from our core Git server. One of us checks them all, does the code review, just basic sort of security checks, and then I'll sync it up to free desktop, so for Joe Public to sort of test out and play with. So, last status. We released 0.18, like a brown paper bag release, about 2 or 3 days ago. We support Canary, Yum, apt, box, ALP, Smart, O-package, that one, Zip. And we're shipped by default in Foresight Linux, which is already tons of users, and the GNOME Developer Kit. So we already have tons and tons of users testing this stuff almost every day. It's going to be shipped in Fedora 9. We don't know if it's going to replace Pirate and the other one, Pup. It'll probably be shipped alongside just for 9, just as a feature preview. But there's also quite a lot of interest from Ubuntu, OpenSUSE, OpenSolaris, Mandriva, and quite a few others that we just can't mention yet. But it's more in the pipeline. So, the release structure. We have rapid development, so there's lots of code churn, lots of API breaks, etc. We do at least a minor release a month, just so everyone can have the latest code. There's about 15 of us, so I guess who are working on the core development. It's all GPL2, so it's very easy to implement into a distro. So, you're thinking, that looks fantastic, but actually, why should I use it? What's the point? I've got tools that already work. Because you can free up developers. If you've got developers that are just sitting there maintaining 15-year-old, 5-year-old tools that aren't going anywhere, you can free them up. We can work together. We can get, okay, GNOME translators do the GNOME bit, KDE bits do the KDE bits. We can work together as a team rather than do per distro. We can get front ends for free. So if you have a distro like, say, Foresight, and you don't want to spend any time on the UI at all, you just do a little bit of code and you get everything that just works for free. And you only really need to provide a very small amount of support, because all you've really written is a 900-line back-end interface. There's a thriving developing team, so if you mail the mailing list, we'll get a response back to you really quickly. So, cool stuff we can do. If we're on a train on GPRS, we probably don't want to do an update, and so we can detect that. We can do system and session inhibit. What that basically means is, per session, I can message GNOME Power Manager and say, I'm doing an RPM transaction, I probably don't want to hibernate or suspend right now, and so I can stop it happening. That's great if you're using GNOME Power Manager. If you're using, say, KDE, or you're not logged in, it also inhibits HAL, which actually stops anything in the session invoking the shutdown method on the PowerSave interface. So even if we haven't got a session running, we can still do a system inhibit to stop you hosing your RPMDB. So, things we haven't got quite right yet. Time remaining. We don't actually know how long something's going to take. And so if I start updating my system, and I've got a lecture in an hour, do I know this update's going to be finished before I leave my lecture? At the moment, what we're doing is we're relying on the percentage changed information from the back end. So if the back end goes 1%, 2%, 3%, 4%, we can have a pretty good guess about when 100% is going to be. And so we can extrapolate that forward. But that's on the assumption that installing takes the same amount of time as downloading, and also that packages like kernel take the same amount of time to download as libsexy. We also haven't really got a good way of reporting bugs in backend. So you can have many transactions queued up very quickly, fire and forget. There could be a bug somewhere which causes one of the transactions to fail. And we've got no real way of reporting that to, say, Bugzilla or to the mailing list. So we need to work on that. We've got a method for it, but we don't actually know how we're going to install service packs. We might just use something like GVFS and hook into the session stuff and detect when the CD's been put in of a certain type, and then run some sort of back-end. We don't really know. That's all up in the air at the moment. So, what have I said? I've discussed all the downsides, or the biggest downsides of the tools we've got already. We've seen how other operating systems do it, OS X, Windows Vista. I've introduced packagekit and the concept of distribution-specific backend. I've shown you the console tools, the Qt tools, the GNOME tools, and how it interacts with packagekit. It seems quite obvious that any of the distros that are using packagekit can share all this common code and this common expertise. And from looking at the blogs and Google, etc., it's quite clear that there's a very strong positive momentum with packagekit. So, I've deliberately kept the questions short, the presentation short, so I can have lots of questions. So, fire away.
Is there a scope for system policy configuration locations so that you can have a centralized config?
Sure, do you mean like policy kit, or do you mean policy kit where you can say which user does what?
Or say things like your update frequency, the default update rules, so you can do that on a system-wide basis without relying on a running applet to provide that configuration. Yeah,
the problem is with a system-wide update, the packagekit daemon only stays alive when it's needed. And so if you wanted something system-wide, you'd have to have a cron job that fired off, say, I don't know, a dbus signal, just to say, update on this day at this time if it's on a server. You could do that, that's no problem at all. The other question, the authentication question, yes, policy kit is per user, but it's also stored centrally per system. And so an admin can define the roles that he wants the users to be able to change, if that makes sense. Does that answer the question?
So you could have your cron job passing the same information as a user applet would do if you wanted to hand over your system administration completely over to packagekit.
Yeah, you could use the pkcon in its script or in a cron job or anything, or you can use dbus directly. Yeah.
Next question. Package IDs.
Yep.
With packagekit, you're letting package names out of this closed domain, which is the distribution-specific package naming. How do you propose to resolve distribution-separate package IDs?
Yeah, excellent question. Basically, how can we have different... In Ubuntu, you might have OpenOffice-bin, and in Fedora, you might have OpenOffice-common, etc. How can you do that? Well, in the example I gave with using libpackagekit in OpenOffice, only the distro knows the name they're going to call something. It's no good for me saying, you must call the package this, because it's never going to wash. It just can't happen. So what I'm suggesting is we use the upstream name. And so something like OpenOffice would say, install OpenOffice-clipart. Now, if Ubuntu changed their OpenOffice-clipart to OpenOffice-clipart-common, they can trivially patch the OpenOffice source code to reflect the new name. I don't think we can sort of say, the same package name has to be used between different distros, because that would be just a massive failure. Does that answer the question?
Desktop files might be easier to do than rely on patching.
Sure. Desktop files are useful for translations, icons, that sort of stuff, but they're not particularly standardized, and there can often be more than one desktop file per application. So something like GNOME Power Manager will have GNOME Power Preferences, GNOME Power Manager, GNOME Power Statistics, that sort of thing. And so you've got to be a bit careful with any heuristics you use. Makes sense. We can talk more in a minute if that's better. That's easier. Anyone else?
You mentioned that you've got questions that you need to ask the user potentially upfront or afterwards.
Yep.
You didn't actually show any examples. How do you do that now?
Sure. At the moment, there are no questions. And so, imagine my mum sitting at home using the computer, and she's updating the system, and libc asks her if it wants to relink the system copy of the binary. That's useless. So my argument is that we should choose the default sane option by default and not tell anyone. And then at the end of the transaction say, there is more information about this transaction in this location if you're bothered. In fact, if you run this program, you can maybe change the default. So I think it should be information rather than a question. If you're that bothered about something, you can go and do something about it. Anyone else?
So just to go back to the package naming problem that the gentleman over there brought up, even though a distro might change the naming scheme of a certain set of packages, so it's no longer following the upstream naming, when you require that the upstream also the distro also patch, say, OpenOffice to use the newer name, you're introducing one more point of failure that things can go wrong. And while you should say that maybe a distro should stick to the upstream naming scheme, I have one comment for you, or one word, is git. And seeing how bad that's cocked up in Fedora, and that actually got fixed because they screwed up upstream, we screwed up downstream, and that was the end of the story. So by requiring a semblance to using the upstream package naming scheme, doesn't that create more points of failure when you have to actually change it, which inevitably every distro is going to do at some point or another?
Sure. I think the question is, can we guarantee the package is going to be correct for the distro? In which case, the distro is the only person out of all the stakeholders in the argument that knows the package name. So if Ubuntu calls something OpenOffice-clipart, and then in the next long-term release call it OpenOffice-clipart-common, we can say they know that this patch only applies for this distribution. We can't really guess that. We can't say you have to call it this, because the logic has to stop somewhere. And my argument is that the distro is the only person that knows what a package is going to be called. It's very difficult to say, install this package that's provided by the file. You can do that in the API, but I think that's a particularly good idea for things like Firefox, Firefox-bin, etc. Does that answer the question?
Not really, but you're right in the sense that we don't have any better solution. I'm just wondering if that's being taken into account as well, that there are more points of failure this way as well.
I'm expecting the distros, if they're picking up packagekit, will be aware of applications that are installing their own files. I think that's important for them to recognize. If they're using the upstream name, they have to make no changes, and so job done. But I think they have to be aware of what's actually being downloaded automatically.
Does packagekit provide API for applications to include a new backend or new repositories on the fly?
Sorry?
Does packagekit provide APIs for applications to add a backend or repositories on the fly? Like, say, Firefox extensions being installed through packagekit, updated, and so on?
That's a common suggestion. At the moment, you can only specify the backend. You can build multiple backends, but you can only run one at a time. Problem being, when you have more than one backend running at the same time, it's very difficult to do dependency resolution because packagekit doesn't do it. And so you have to rely on two tools to do essentially the same thing. Packagekit's basically said to the tool underneath, you do the dependency resolution, you know what you're doing, and I'll just do the pretty bit. I'll do the common interface. And so if we have two sources, we don't really want to get involved in the dependency resolution with xp.com or something from one repository and not the other. With regards to the question for like Firefox Updater, I think that should be handled by the distro rather than by the application. And so the Firefox application itself could be patched to use packagekit to update itself using the correct name from the distribution's repositories rather than going to look on mozilla.whatever.org. As soon as you let applications start adding their own backends, you start getting horrible, horrible dependency problems. Does that answer the question?
Yeah, more or less. I mean, I'm thinking about applications that would want to install stuff that's not used by RPMs and packages like that. So if you want to install something like, I mean, I'm from Fluendo installing codec packs in the user directory. That's not used any package, but it would be nice if that can be handled by a nice updater system.
Sure. I think with packagekit, it's important to think of things per system. I think as soon as you start looking at the problem per system and per session, I think the problem gets somehow like much more complicated. I do think there's a use case for that, but I think it could be maybe better if the Fluendo stuff could be installed per system using packagekit, using an existing distro package, for instance, or using a repository which you add yourself, because then you can do the updates from it yourself as well.
Okay, thanks.
Hi, very short question. Is there any word on Vala bindings?
I'm sorry?
Is there any word on Vala bindings? I saw it was written in G-object, but are there any Vala bindings yet?
I'm sorry, I really can't hear you.
V-A-L-A.
Vala? Oh my word. There isn't, but packagekit itself is really just a dbus sort of multiplexing thing. It's really not that complicated. And so a Vala binding would literally be something like, just like a G-object binding like I've done in the source tree. It'd be trivial, absolutely trivial, 10 minutes work.
I have a more user question.
Yep.
What I really don't like about pub, and correct me if I'm wrong, is the simple distinction between tracking of updates. That's either all or just security. Can you somehow subscribe to updates for only one application?
Yeah, you could do, but the question is why would you want to? If a security update is available for distribution, it's probably quite important you do it straight away.
No, it's more just, and security and maybe one or two applications that I'm interested in, but not in all of the system.
In that case, you can use, there's an update viewer application which actually lists every single update individually, and you can select which updates you want to apply one by one.
But that's manual. It doesn't warn me if something is available or something like that.
Sure. I can't see a concrete use case for only updating just the one application. I can see a use case for not updating certain applications, and maybe we can work that into somehow the package itself. You've got to think a common use case is you've got to think, if you try to solve every single use case, every single part of the packaging problem, you get a system that just cannot work.
Well, it's just about avoiding update everything and still keeping it so just track the one that you're interested in or the few and just avoid the risk to update stuff that you aren't really that interested in.
Sure. I guess you could do an update per repository, and so you could only enable updates for a single repository. I'm not sure it'd be possible with packagekit to do it per package. I think that's too specific a use case. There's no reason you couldn't write a tool to do that in like libpackagekit, which is a simple G object, nice little object, and do just that. I don't think it's a part of core packagekit. Sorry. Anyone else?
Hi, I have developer questions. I have been looking how to create backends for packagekit, and there are some oversimplifications in the dependency handling. For example, in RPM you have this requires, and a provide is an arbitrary string, for example. So a package can require some web server string, and this is not provided by any packages in the world of repositories you have. But in the packagekit API, for example, every package has, when you say get dependencies, you actually you get the ID of the dependent package, and this cannot be available at all. Or in the opposite case, that there are a lot of packages providing this dependency. All of them will match. Which one should you give to the user and show this package depend on all of them or known? What is going to happen with these simplifications?
So I think the question you're really asking is, if you want just a web browser installed as a dependency, how does packagekit decide which web browser to install?
If I browse, for example, in the package selector, and I select the package and I want to see more information about it, what it depends on, and there are a lot of packages providing this dependency. What do you have to show to the user? Because packagekit actually is enforcing one ID of the package you have to return, and this package has to belong to that world.
So what you're saying is packagekit is forcing a hard dependency on certain things.
Exactly.
Sure. That's probably just a limitation of the API. If that is useful for a general use case, I think that is useful in the API. At the moment, we haven't found a use for that in an application. So I think it's quite important with packagekit to concentrate on the use cases for the common case, rather than trying to bloat the API out for confusing the general case. If we did need that for application, I'd have no problems adding that to the API. Does that answer your question?
Yeah, more or less. My question was mostly about if you have different backends and they are giving you different results. For for really basic users, it might be sufficient. But other people trying to use trying to embrace the packagekit tools, they can get confused when they get strange results they are not used to.
Okay, I've struggled to hear that, but I'll answer what I think I heard. I think, can anyone sort of summarise? Okay. Could you just repeat the question really quickly? Sorry.
For example, if I use the native tools in SUSE, and some package depends on a web server package, which is provided by a lot of them, I will be able to see those alternatives, or if there is none, I will get an error. There is no package providing this.
Sure.
But in packagekit, you have to find actually this, you have to return something. And if there are multiple packages providing something, you have to tell the user, this package depends on all of them, or selecting one of them, which moves the policies to packagekit itself.
Yeah, it's a valid question, but is it useful? So if my mum's using a computer and she wants to install some sort of application sharing, and she needs HTTPD or any web server, I don't think it matters to her what she's using. So if we choose a same default, I think in the Canary backend, we've got an algorithm that chooses a same default. I guess that's distro specific. Chat in a minute and we'll talk about it in more detail. Cheers.
Okay, well that rounds up the questions. So thanks very much, Richard.